Oh, hey guys, this is Mr. Thompson. Today we're going to be talking about empirical formula, how to find the empirical formula of a compound. Now, you should have already gone over percent composition. If you haven't, you need to catch my other video and make sure that you understand that. But today we're going to be using a little bit of that information to kind of figure out what the formula is that we're working with based on the percentages that we're given. So let's talk a little bit about what empirical formula means. Well, an empirical formula is just simply a ratio of the elements in there. So it's not going to be the actual formula that we're working with. It's a simple ratio. Okay, so for example, if we were talking about a classroom, I might say that there are 2 boys for every 3 girls. Now, it doesn't mean that there's going to be only 2 boys and 3 girls in there, so just 5 students. It's just a ratio. I could have any number of students. As long as I keep that 2 to 3 ratio, there could be 10 boys and 15 girls, or 20 and 30, but that 2 to 3 ratio stays the same. We're going to do the same thing with these formulas. It's just going to be a ratio. So the empirical formula for this particular compound is CH2O. Now, that does not tell me how many of each there are. It just says that if I have 1 carbon, I'll have 2 hydrogen and 1 oxygen. If I have more than that, here's some example formulas. I could have 2 carbon, 4 hydrogen, 2 oxygen. A common one that you see, which is sucrose, is C6H12O6. Again, twice as many hydrogen as there are the other 2. So that's what empirical formula is. Not too complicated. Don't worry too much about it. Think of it more as a ratio and not a formula. To find the empirical formula after you've given some information, there are several rules that you have. 4 steps that we have to do to find the empirical formula correctly. Step 1, they're going to give us some percent. So for instance, I might say that there's 35.6% of something. What we're going to do, we're going to keep it nice and simple. That percent is going to become the number of grams. It just keeps it real easy. We don't have to do any conversion, nothing like that. So 35.6% becomes 35.6 grams. Now for step 2, we're going to take each of the masses that they give us for each one of the elements, and we're going to divide by the molar mass of that element. Now you're going to find that on the periodic table. So for instance, if I've given oxygen, I would go to my periodic table. Oxygen's atomic mass is 15.999. So I would divide whatever number they gave me by 15.999, and I would get the number of moles. And once I have each one of those mole measurements, I'm going to divide each one of those by the smallest measure of moles. So if I have 2 moles and 4 moles, I'm going to divide each of those by the smaller number. So I'm going to divide each of them by 2. And step 4, if you get a decimal that's close to a whole number, like you get 2.1 or 2.05 or something like that, round that off. It goes to 2. Now, if it's something that's not really close, like say 3.5 or 3.4 or something like that, you need to pick a number to multiply it by to get rid of that decimal. And we're going to look at some examples like that, okay? But let's just start off with an easy example so you can see. Remember, pause the video if you want to write down those steps, or even better, come back to these after you see an example, and then the steps should make some more sense and you can write them down in your notes. So for example, I have a compound that is made of 63% manganese and 37% oxygen. I want to know, what is the empirical formula for this compound? So step 1, we're going to convert all those percentages into grams. 63 grams of manganese, 37 grams of oxygen. Nothing funny there. Okay? Step 2, I'm going to convert both of these into moles, so I'm going to go to my periodic table. I have 63 grams of manganese on the periodic table. Manganese has a molar mass of 54.938. You get that straight off the periodic table. I'm going to divide. I get 1.15 moles. Same thing for oxygen. 37 divided by that molar mass, I get 2.31 moles of oxygen. Step 3. I'm going to take both of those numbers, 1.15 and 2.31, and I'm going to divide by the smaller number. In this case, it's 1.15. So of course, 1.15 divided by, I get 1. For the oxygen, 2.31 divided by 1.15, you go to your calculator, you get 2.01, which we're going to round that off. My formula has 1 manganese and 2 oxygen, so the last step, I'm going to round it off and I'm going to write that, MnO2. And that's all there is to it. Really simple, really straightforward, okay? But you got to have those steps, and that's going to be the tricky part, is remembering the 4 steps, which is why we're going to practice with this quite a bit in class.